So, good evening, everyone. So, welcome to my YouTube channel, Maths of Theorem. So, today we are going to see uh, sandwich theorem on limits. Okay. So, result let hxy, fxy, and gxy be functions such that hxy is less than fxy less than gxy with limit xy tending to x naught, y naught, hx, and limit xy tending to x naught, y naught, gxy exist. Also, both limits are equal. Let's say L. Okay. Then limit xy tending to x naught, y naught, fxy also exist, and that is limit equal to xy tending to x naught, y naught, fxy is equal to L. Let's see its proof. Let epsilon greater than 0. So limit xy tending to x naught, y naught, gxy is equal to L implies there exists delta 1 greater than 0 such that gxy minus L less than epsilon for all x minus x naught square plus y minus y naught square less than delta 1. Okay. So how we can write this? This means L minus epsilon gxy L plus epsilon for all xy such with x minus x naught square y minus y naught square less than delta 1. So this implies fxy that is less than gxy less than L plus epsilon for all xy with x minus x naught square y minus y naught square less than delta 1. Okay, so that means fxy less than L plus epsilon for all xy with x minus x naught plus y minus y naught less than delta. Let's see equation number 1. Okay, again limit xy tending to x naught y naught hxy is equal to L implies there exists delta 2 greater than 0 such that such that hxy minus L less than epsilon for all xy with under root x minus x naught plus y minus y naught square less than delta. So this implies L minus epsilon less than fxy less than L plus epsilon for all xy with x minus x naught square y minus y naught square less than delta. Okay, so this implies L minus epsilon is greater than is less than fxy, but this is less than fxy for all xy with x minus x naught plus y minus y naught square less than delta two. Okay, so that means L minus epsilon is less than fxy for all xy with x minus x naught square y minus y naught square less than delta. That's it. Put delta is equal to minimum of delta 1, delta 2 greater than this. Then from 1 and 2 we have L minus epsilon less than fxy less than L plus epsilon for all xy with x minus x naught square plus y minus y naught square less than delta. What is the meaning of this? This implies limit xy tending to x naught y naught fxy exists and limit xy okay tending to x naught y naught is equal to L. Okay, So we can write actually this part. What is this part? We can write f x y minus L less than epsilon for all x y with x minus x naught square plus y minus y naught square less than delta. Okay, so this we have. Okay. Note that no limit x y tending to x naught y naught fx y is equal to 0 if and only if limit x y tending to x naught y naught fx y is equal to 0. Mod. It is easy to verify. It is easy to verify. Let's see it proves. So let limit x y tending to x naught y naught fx y is equal to 0. Let epsilon greater than 0. Okay. Then here exists delta greater than 0 such that f x y is less than epsilon for all x y with x square plus y square less than delta. So this part can be written as this also. For all x y with x square plus y square less than delta. What is the meaning of this? This means limit x y tending to x naught y naught f x y is equal to okay. Now conversely, let limit x y tending to x naught y naught f x y is equal to 0. Let epsilon greater than 0. Then there exists delta greater than 0 such that f x y less than epsilon for all x y with x square plus y square less than delta. But this is inside thing is non-negative, so we can write like that also. Okay. So what is the meaning of this? Meaning of this is limit x y tending to x naught y naught of x y is equal to 0. Okay. 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 So example, does limit xy tending to 0, 0 y sine 1 upon x exist? Solution. So we know that this happens. Okay, this happens. Now you see that limit xy tending to 0, 0. What is, let's say this is fxy, this is my fxy, and this is my gxy. So hxy limit is what? Because it is itself 0. It is itself 0. So what will be the limit? Limit will be 0. Okay. And what our limit? Xy tending to x naught, y naught. We have already checked. What is the limit of this? This is also 0. So by sandwich theorem, limit xy tending to x naught, xy tending to 0, 0, x sine y sine 1 upon x, that is 0. Because this is absolute, so this is if and only limit xy tending to 0, 0 y sine 1 upon x is 0. Okay, so limit exists and that is equal to this. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. So thank you very much for today's lecture. Thank you very much. We will see you for next lecture.